本日は RRI 国際審
Thank you very much for joining us at the Robot Revolution and Industrial IoT International Symposium 2022. This year's theme is Manufacturing as the Foundation of All Industries. Especially today, from Europe, the US, and from Japan, we have panelists who will be talking about the collaborative system, PSSs, as a social infrastructure. They will be making presentations and having discussion on this topic. My name is Irie, the co-chair person of Working Group 1 at RRI, and I'm also senior strategist in Hitachi. Let me share my screen.
確認というか紹介したいと思います。これ
And I'm going to talk about the purpose of today's symposium. It is shown on the website as well. Based on the introduction of the trends in each region and the discussion of day one yesterday, we will focus on these areas underlined in the slide: manufacturing as a social infrastructure in the digital age that supports sustainable development and have the resilience for changes. Thank you very much for joining us once again. And now let me introduce the speakers. We have Professor Dr. Henning Kagermann, Chairman of the Acatech Board of Trustees. And second speaker is Mr. John Dyck, CEO of Clean Energy Smart Manufacturing Innovation Institute, or SESMI for short. And the third speaker is Mr. Kiyoshi Mizukami, Industrial IoT Advisor in Working Group 1 at RRI. Thank you very much for joining us. Before we begin the session, I have a request to the audience. Before the panel discussion, if you have any questions, please go to the description box of YouTube, as you can see on this slide, and click on the link and open Slido, where you can post your question as well as your name and affiliation. We welcome your questions and comments. Now, without further ado, we want to move on to the speeches. The first presentation is titled as Sustainable and Resilient Digital Ecosystems. Dr. Kagermann, the floor is yours.
Ladies and gentlemen, dear friends, every time when we met, there were new challenges in the past, and this time we are confronted with an unprecedented accumulation of crises. Obviously, the leadership of the Platform Industry 4.0 has reviewed its vision that was outlined 3 years ago for 2030, and we have nevertheless confirmed our vision, but with adapted priorities, as you can see in the first slide. This is the old slide, but I have highlighted the 3 topics which are now with utmost priorities of our mind, and I will touch on all 3 of them during my presentation. Started with circular economy, following with resilient supply chains, and ending up with something which is in particular on my mind. These are adaptable ecosystems. Circular economy is not a new initiative. It was actually put on the agenda from the European Commission already 2015, and it was recently reconfirmed, as you can see here, in 2020 with a so-called Circular Economy Action Plan, which stated that circular economy is integral and essential for achieving the ambition of Europe, which is outlined in the Green New Deal. And they requested the industrial associations of the different countries to implement the Sustainable Product Initiative, which was proposed by the Commission. In Germany, that was easily done by our BDI because they could base their ideas on recommendations that were developed by a project team orchestrated by acatech a few years ago, the so-called Circular Economy Initiative in Germany. Now, the Circular Economy Initiative based its recommendation on the well-known idea that it's about decoupling economic growth from resource consumption. We collected many experts from all societal groups. You can see the involvement of 3 ministries, companies from different industry, large and small ones, scientific institutions, the academies, and from a civil society organizations like the World Economic Forum. And the topic is to review the collaboration along the entire value chain. But because it's such a broad topic, I think they have focused on 3 areas, which I will highlight in detail in the next slide. Very important, the recommendations are published in English, and if you are interested, you can find them on acatech's website. Now, the key observation of circular economy is that there is considerable structural waste in all current value chains. And if you look to the 3 topics we have highlighted, you can see the following observations. First of all, it's about circular business models, because today only 5% of raw material is restored after first use, which means we have to take a holistic life cycle approach. The second one is because it's so much so urgent that we have to look to plastics and packaging. And even here, only 2% is recycled today into quality materials. And finally, because we all try to move to zero-emission vehicles, in particular, electric vehicles are of high importance for our government. So the question is what to do with the traction batteries and their recycling, because only 25% of the cost are, because 25% are attributed to metallic materials. And there is already a follow-up initiative, it's called the Battery Passport, where we use the concept, which I will explain again later, of the asset administration shell to do such a digital twin for the battery. And that is so successful that meanwhile people believe that could be a blueprint for a general product passport promoted by the European Commission. So let me dig into this life cycle approach. This is a picture which was published a few years ago from BCG, and I have picked this and taken into my presentations just to highlight the key topics. It starts with a circular material system using more recycled materials. In design, it's mostly about upcycling, a concept which we recommended already 2011 as a base of Industry 4.0. You know that we start to transform our manufacturing system towards the concepts of Industry 4.0 to be resource and energy efficient. We have outlined with smart services the business model of the digital age, which is value-oriented and more towards as-a-service offerings, which is implementing a shared economy. And we shouldn't forget that we need a kind of a recollection infrastructure, which we don't have so far, in order, let's say, to make recycling more profitable. Now I want to go step by step into these points. First, circular material systems. The idea is to copy nature because circularity is built into biological systems, and therefore the recommendation is to use more organic material, what is done partially also in the automotive industry. If that's not possible, go more for biosynthetically produced ones, or at least for bio-inspired ones. Another point which is important is that we design systems in a way that you keep biological and technical material separate, so that at the end of the life cycle, it's easier to put safely the biological part back into biosphere. The second step is eco-design, and that is, again, thinking not so much about recycling, but much more about reusability. And today, I think our design isn't done in a way that neither recycling nor reusability is done in a profitable way. So it's about the ability to repair products, to reuse them, to refurbish them, to remanufacture certain components, and then as a final step, to look that we can recycle them more easily. That means we have to look to our design in 3 steps. We have to understand what makes a product sustainable, then design it for circular business models, and finally come to sustainable manufacturing solutions, which is one of the topics we will discuss also today. Now, if you look to the transformation of the digital factory into smart manufacturing, you know that we are doing this now since 10 years with Industry 4.0. In the center is the concept of the digital twin, which is the representation, a virtual representation of the reality implemented by the asset administration shell, if you want, a collection of a variety of models for the different aspects of manufacturing based on international accepted standards. In addition, important is the shift from on-premise software to cloud, different types of cloud, and then to edge computing. We call it these days an edge cloud continuum. And if you look to the, I would say, mega trends, which we now have in front of us after having done a lot of work, in particular in the connectivity of the shop floor. These are industrial artificial intelligence. This is, as I said, edge computing up to an edge cloud. It's 5G. In the factory, it's team robotics. It's autonomous intralogistic systems and trustworthy data infrastructure. So that's what we are promoting next. And the goal, or one of the goals in the next phase, is zero defect production. This is an example, let's say, to show that the digital twin is also a good foundation if it comes to, let's say, not only for collaboration, but also for sustainability. In collaboration with our American colleagues, the Platform Industry 4.0 has developed and published last year a fact sheet how we can easily exchange data across the value chain about CO2 consumption in order to get the entire footprint. The asset administration shell was used for that. What's necessary, obviously, is to have a telemetry in order to measure the consumption in a consistent way. Yet this can be done with own calculations, but it would be more important if everybody would use the same external cloud services linked via OPC-UA to make the calculation consistent. Now let's look to the next topic. I think at the heart are these two notions of digital twin and data spaces, because if you want to build digital ecosystems, and if you want, let's say, to have transparency across the entire value chain in order to come to more resilient supply chains, you have, let's say, to have transparency of data and information. You need a way that you can share information in a trustworthy way with sovereignty of data for the individual stakeholders. And as you know, that was done a few years ago with Gaia X, where we have taken a federated approach, a peer-to-peer connectivity and exchange of data with complete data sovereignty for the members of a data space. It's in a way a foundation, therefore, for a connected economy. We outlined all the architectural principles because that is based on common architecture. And in the meantime, the Gaia X consortium has also developed certain general services which are necessary to make those things happen. There are many, many use cases built on Gaia X in the meantime, but I think the most important one is Catena X, which was, as far as I know, presented on yesterday's part. And this is, let's say, making data exchange secure across the entire automotive value chain. We feel that is a key use case in order to prove the ability of Gaia X. And it's not a surprise that the colleagues from the Platform Industry 4.0 had the idea, I would say 9 months ago, to build a similar data space on top of this infrastructure for the entire manufacturing community called Manufacturing X, using and exploiting the benefits and the experience we gain through Catena X, and to some extent building a data sharing community for the industry of the future. And I think that will be the next big project we kick off. Now, let me switch to the second point I mentioned, supply chain resilience. That is also not a new topic. I'm a little bit surprised. We highlighted these in 2008-9 after the economic crisis, but it was a little bit forgotten in the society and in the government. So with the pandemic coming up, it became a hot topic again. And at our academy, we published a number of reports, which we also discussed with the top of our government. These reports are available in English, and I pick the example of the automotive industry. We have also done a report on the health care industry for obvious reasons. And you see here in the recommendations more or less the same notions and topics popping up again. It started with we have to increase our adaptability. That means we have to accelerate the implementation of Industry 4.0 principles. We have to ease the collaboration amongst players of the same industry, the pre-competitive collaboration. We have seen that we have broken supply chains, in particular around microelectronics in Europe. Europe is consuming 20% of the chips, but producing only 10% itself. In 2015, we launched our first important project of common European interest on microelectronics that worked well. So now we recommend a second phase, which is already underway, and might be you have seen that there is also a collaboration with Intel, and they will build larger factories in the north of Germany. Another point is obviously promote circular economy. I spoke about that. And continue to implement data spaces as soon as you can. So that fits to some extent nicely together. What I felt might be of interest is to see that also people were looking to different ideas in order to scale production. When the pandemic came up, you know, there was a big debate, what can we do for developing countries, in particular in Africa, where the vaccination rate is very, very low. There was the idea to release the patents, but that cannot be the solution. If you look, for example, to the vaccine, let's say, developed by BioNTech and Pfizer, and produced by both companies, then this, let's say, production is pretty sophisticated. It cannot easily be copied. And therefore, the idea was, in order to localize production, which makes it also more resilient, to develop a self-sufficient production environment within 6 physical containers, as you can see here on the slide. So have a kind of a modular production facility, which is able to produce 50 million doses a year and ship them to certain African countries, and to do those things locally. And you can see in the middle with which countries the EU has, let's say, cooperated. I think that's it's a good idea in order to bring production to local environments, in addition to 3D printing, what we were discussing for many, many years. Now, coming to the third point, it's adaptable ecosystems. I think we speak a lot about digital ecosystems, but the point is, if it's about resilience, then it could be that despite all the efforts we are doing in order to have diversification, so that C might be having 2 different providers of the same service in the ecosystem, that both of them, let's say, are not able to provide the services we need for whatever reasons. So you have to onboard new provider of this service into your ecosystem. And this easy onboarding is a very difficult task. We talk about since more than 10 years, but progress is very slow. And it's slow because we did very well in semantic interoperability from a technological point of view. But now we have to expand this to the commercial and legal side. What we are doing, but you can imagine this is much more difficult. The basis, I think, has been established with the digital twin and the data spaces, because it gives us the tools to monitor, predict, and act in principle in real time. The transparency is there. But in order to make it happen, you need a kind of an ad hoc networking, and that I call is a seamless onboarding of new business partners. With seamless, I mean, might be in a day or 2 days, but then you need a kind of a handshake also on the commercial side. And in analogy of what we required from the factory, where we said plug and produce, I call this connect and transact. And that's something I think we have to do in the next step. So in order to summarize these, I have presented 2 slides. First, to highlight what this means for enterprises. And everybody speaks these days about a twin transformation, green and digital. But in reality, in particular in Germany, and I think in Japan, not so much in the US, by the way, John, it's a triple transformation. We also have a demographic change, and we have to see that we accelerate the digital transformation, because at least in Germany, we believe that the efforts coming from digitization will not fill the gaps we have on the supply side of experienced people. So that means we have to, let's say, accelerate this revolution of automation using artificial intelligence, in particular in the industrial space, as it means, first of all, that all companies have to do another business process re-engineering, something we did 15, 20 years ago. But now, with having the capabilities of artificial intelligence in mind and reconsidering the different tasks within the business processes and decide which one can be easily be automated, because these are routine tasks or will be routine tasks in the year to come, and which one are more, we call them situational, which are changing, which necessarily needs the involvement of people, which is a kind of collaboration of people of different departments in different companies. And that means we have to, let's say, also think about our business ecosystem engagement, because these networks are different if you are more on the, I would say, creative side, if you do a design and research and development network, or if you go down the supply chain more into the operation and the delivery. So therefore, the point is business process re-engineering eco-design, as I outlined, on business ecosystem engagement. And finally, if you look to the societies and what it means for our industries is what I just highlighted. Look to these 3 points and follow the actions. From the workforce point of view, we need much more upskilling and have to implement cognitive robotics let's say foster the human-machine interaction. People have to be aware that, let's say, their skills and capabilities are outdated, let's say, over several years. So lifelong learning is, let's say, in the center of what we discuss with human resource executives of various industries. And finally, if it comes to us, the consumer, if you look to the cycles, and you can see that at the end of the day, if it comes to a sharing economy, and if it comes to, let's say, accepting as a service offerings, and we need a social innovation that, for example, if you look to the car industry, that people accept instead of getting, let's say, a car to get a mobility budget. That, as I would call, social innovations. I would like to close with that, and let me say in finishing that in these days where we have an unprecedented accumulation of crises, it's of utmost importance that we have systemic thinking and to continue our collaboration on a global scale. Thank you very much.
Well, はい、Kagermann先生、どうもありがとう。
Dr. Kagermann, thank you very much. Next presentation is titled Partnering to Drive Interoperability and Harmonization. From Sesame, Mr. Dyck, the floor is yours.
Well, greetings from the United States of America. It's a pleasure to be with you and a real honor to be presenting briefly our story for your audience today. My name is John Dyck. I'm the Chief Executive Officer of SESME, which stands for the Clean Energy Smart Manufacturing Innovation Institute. We refer to ourselves more briefly as the Smart Manufacturing Institute. Let me share my desktop for you this morning. I guess this evening where you are. And as noted, the discussion I'd like to have with you today is around how we're partnering with Japan, Germany, and other really important manufacturing regions in the world to drive interoperability and harmonization. We believe that manufacturing is a global enterprise and that it's vital for us to ensure harmonization of these activities. As these initiatives gain momentum and traction in our own country, it's more and more important to ensure that the work that we're doing is consistent and as aligned as possible from a standards advocacy perspective and from an actual desired outcome perspective. A little bit about SESME. We are funded by the Department of Energy here in the US and have a specific set of funds dedicated to driving research and development and innovation in the realm of smart manufacturing. Our goal is to create a more competitive manufacturing operation here in the US, and of course, by extension of our global enterprises, doing so in a global manner. Our ecosystem, as we've defined it here, includes the manufacturers, obviously, the systems integration community and the consultants, the technology providers, the machine builders, and of course, academia, labs, the not-for-profit organizations that are such a vital part of the talent pipeline and ensuring that we create the right context for social and technology innovation here in this country. We do so by convening this great collection of these stakeholders. Let me go back here. We are very proactive in ensuring that we have a healthy mix of each of those 5 stakeholder groups here in the US. and working together to develop a roadmap that allows us to accomplish the objectives of the Institute, which is to, as I mentioned, to create a more competitive manufacturing enterprise. My slide presentation is advancing automatically, and I apologize for the transitions here. Our vision here at SESME is to accelerate the democratization of smart manufacturing. In essence, what that means to us is that the cost and complexity of implementing smart manufacturing systems and solutions and technology is still far too complex and far too costly. And so most of the effort and the investment that we're making here at SESME is around reducing cost and reducing complexity. And we've focused specifically on these three pillars to reduce the cost and complexity of technology implementation, to reduce the cost and complexity of how knowledge is disseminated across this ecosystem for every stakeholder, and of course, the innovation ecosystem, working to make sure that we move from a far less proprietary approach to building smart manufacturing ecosystems and collaborating much more effectively across different stakeholder types to ensure that we have the desired outcomes that we're looking for across this country. I'd like to speak for a moment about our current challenges and the outcome of really 40 years of Industry 3.0, the idea that for any great manufacturer, when you have the challenge to connect your manufacturing assets and try to create more value from your existing assets, which is the primary goal for most digital transformation, Industry 4.0 and smart manufacturing initiatives, the challenge today is that every manufacturer goes through a very similar process of selecting a great vendor, selecting the expertise, the subject matter experts to implement that system, and then of course works on developing the solutions required to achieve those desired outcomes. But the challenge is that every time, for every initiative, for every technology, that implementation starts from scratch every single time. We know broadly that 80% of any solution like this, for any implementation like this, 80% of the time and the cost is spent building the infrastructure, and 20% of the time is spent building the actual desired outcomes, creating value, if you will. But at the end of the day, for the last 40 years, every single one of those implementations results in a custom, proprietary, non-portable set of outcomes with very little reusability from one project to the next. And this is what has resulted in a level of technical debt that makes it extremely difficult for manufacturers to adopt innovation and to engage in the fourth industrial revolution at scale. I think from a US perspective, we have fallen behind in terms of the adoption of smart manufacturing. And it's vital to understand why we have fallen behind and what we can do to change that and to ensure that we simplify and create the right environment for aggressive innovation in the years to come. This is an actual manufacturing systems taxonomy from a large manufacturer here in the US. It happens to be one of the most mature manufacturers that I've ever met. Each one of these boxes is an actual manufacturing system sanctioned by their organization and rolled out across close to 70 of their manufacturing plants. Every one of these systems has its own manufacturing systems infrastructure, its IT infrastructure, its connectivity to the shop floor, its own user experience. And yet, at the end of every shift, in every plant, they spend 40 hours extracting data from these systems to print reports and to allow a shift handoff from one shift to the next. And this is, as I mentioned, one of the most mature manufacturers in the country. And this is what we found to be consistent across the US, likely around the world, this level of technical debt that we've created for our manufacturers, which dramatically inhibits or prevents investment in new technologies. And so as we've looked across this landscape to see what are the challenges, what are the opportunities, and how can SESME fund innovation to reduce cost and complexity and ensure that not just the large manufacturers, but also the small and mid-sized manufacturers have access to these important technologies, we've recognized that we have to work together in a much more collaborative way to ensure that we can move the entire ecosystem effectively from our what we call Industry 3.0 approach to manufacturing systems implementation to a smart manufacturing environment. We've done the analysis on the left-hand side to define or to indicate where we are today. Even after 11 years of talking about the fourth industrial revolution, we would state quite clearly that most manufacturers and most of this ecosystem is still very much on the Industry 3.0 side of this chasm, characterized, as you see here, by proprietary systems, very little interoperability, data silos for each of those boxes, stovepiped architectures, vendor lock-in, very little application portability, and of course, difficulty to scale. And when I talk about scaling, mostly I mean scaling down to the small and mid-sized manufacturers so that they too might access these vital systems and these vital capabilities. So in the same way, we've defined the smart manufacturing first principles as the aspiration for any smart manufacturing or Industry 4.0 technology. If you claim to be an Industry 4.0 or a smart manufacturing provider, this ought to be the hallmark of your capabilities, starting with interoperability and openness, and sustainable and energy efficient, and secure, and scalable, and resilient and orchestrated, and flat and real time, and proactive and semi-autonomous. These are the first principles of smart manufacturing, and it's by focusing on these attributes that we believe that we will be able to facilitate a manufacturing future where all manufacturers have access to these important technologies, these important transformational capabilities across their culture and their organization. One of the important activities that we have been focused on recently is to really understand where smart manufacturing innovation is happening in each part of these ecosystems, because for this accelerated adoption of smart manufacturing, we have to ensure that the entire ecosystem is coming along and is part of that process, part of that transformation. And so we've worked with the manufacturing organizations, with the OT vendors, the IT vendors, the systems integrators and consultants, machine builders, and academia to understand where they are on their maturity of evolving from Industry 3.0 to Industry 4.0, and ensuring that we, in the process of investing in these capabilities over time, that we provide not just the knowledge and not just the technology, but also ensuring that we provide and do so in a way that provides an effective business model for them to be incentivized to engage in these new and disruptive capabilities. And that's been a really important realization for us to ensure that the entire ecosystem is engaging. On the technology side, we actually worked together to redefine what a true Industrie 4.0 compliant manufacturing architecture looks like, with interoperability as a key enabler. So we've built the smart manufacturing specifications that define the edges of each of these layers. And then we've actually invested in fulfilling and building our implementation of a smart manufacturing platform, a smart manufacturing marketplace, and then funding the creation of a next generation set of applications, a next generation set of information models. Dr. Kagermann spoke about asset administration shell as an important enabler for Industrie 4.0 in Germany. We've been working closely with Germany on ensuring that our efforts around information model standardization are aligned, and we have built the technology exchange so that our efforts in the US around information models and the asset administration shell are completely compatible and can be used in any environment where this architecture exists. So the marketplace is an essential place for any manufacturer to access these capabilities, the open source code, the applications, the tools, and the information model designer tools that we've built to facilitate this kind of transformation. It's this level of interoperability that we believe is essential for manufacturing. This is one example of the types of engagement that we've been focused on with the OPC Foundation to ensure that we have not just the actual information models, but a repository, a standards-based, extensible, open library for these information models, so that as well as the information models, the repository of that set of information models is accessible anywhere around the world. So SESME, together with the OPC Foundation, built a joint working group with these great organizations that you see here, including all three of the big hyperscale cloud providers, to build this cloud library specification, and then the actual implementation of that cloud library, which, by the way, is now the repository for the SESME smart manufacturing marketplace that I just spoke about. And it's these types of activities that we want to ensure happen in the context of our work with Japan, and our work with Germany, and ensuring that the education, the knowledge, the standards advocacy, and of course the technology framework that we're developing are done in harmony with each other, so that we're driving these capabilities forward in a manner that is adoptable and consistent globally. On the knowledge side, on the education side, and particularly in the context of small, mid-sized manufacturers, we want to ensure that they too have access to these important capabilities. I know it's different in much of Europe and Asia, but in the US, most of these Industrie 4.0 capabilities are aimed at the large manufacturing enterprise. And most small and mid-sized manufacturers find it very difficult to access and to be able to afford and sustain these important capabilities. So we've built a set of tools, a smart manufacturing business assessment, a road mapping process, and a number of important tools that we are giving back to the industry to ensure that these small and mid-sized manufacturers have a way to engage, that they can work through and understand the value proposition of these important capabilities in the context of a small manufacturing operation, and understanding where their gaps are and how they can build a strategic long-term roadmap that consists not just of a technology roadmap, but of a strategy roadmap, culture, business process, systems, workforce, and of course, supply chain. Because these same challenges and these same opportunities represented in plant operations, obviously are completely extensible into the enterprise and, of course, into the manufacturing supply chain. I want to wrap up by drawing an important analogy here. We talked about the complexity that we have created for ourselves through Industry 3.0. What I want to articulate is that for the most part, the data silos and the stovepipe architectures that we've created for ourselves have really constrained the flow of information from manufacturing operations to the plants, to the enterprise and the supply chain. And that looking forward, the technology and the knowledge strategy developed by SESME and our members is very much about ensuring that information flow can happen in real time from any layer in our manufacturing operations to any other layer in manufacturing operations. And it's the creation of this harmonized smart manufacturing infrastructure that we can facilitate that, ensuring that this kind of, without taking anything away from the legacy that we've created for ourselves, we enable a transition to a more interoperable, more open, more real-time future for our manufacturers here in this country. And with that, I'd like to close with this final slide just to underscore the idea that smart manufacturing cannot happen in the context of just one organization. This is an ecosystem challenge. This is an ecosystem opportunity. And we have to ensure in very practical ways that, as I mentioned before, we engage this entire ecosystem in ways that their business models and ways that their capabilities can accelerate across this great digital divide and ensure that our social and broad strategic initiatives are aligned and can be invested in at scale. With that, I'll hand the floor back to you.
Dyck-sama、本当にありがとうございます。
Dyck-san, thank you very much. Now we will move on to the next presentation. The next presentation is domestic trends and significance of manufacturing in the next industrial structure. So we will hand over to Mizukami-san. I am Mizukami from RRI. In 2015, when RRI was established, I was involved in this activity. So, Kamoto-san, thank you always, every day, every year. In 2018, we had a discussion on B2B platform. You asked me to join, and in 2019, you accepted the delegation from Germany. So I really thank the opportunity, and I'm very happy to be able to be involved in this way. So, Dyck-san, thank you for your presentation last year, and nice to meet you. I think you talked about the education last time, and I think this is a very important keyword. And yesterday, the Volkswagen person talked about the importance of the collaboration, and we need to have a good understanding of this so that we can collaborate even further. So now we will move on to my presentation. Today, as was introduced earlier, I will talk about the trends in Japan and about the manufacturing technology. I want to understand how important this is and the weight it has. So that will be the main theme of my presentation. So I'll cover those 2 points. First of all, I would like to talk about what is happening in Japan. So I will introduce to you 2 different organizations. So in Japan, finally, we are starting to see those kind of activities and movements starting to take place. And this is in Hanover Messe, we presented how we're moving towards a society 5.0 in Japan. Connected industries is the slogan that we put together in 2017 or 2018. And together with the Japanese government, in the manufacturing robotics space, we have been taking on this role recently. For example, the architecture or data ecosystem are becoming more important as a topic. And there's Architecture Design Center for Architecture for a Data Ecosystem. We have this Data Society Alliance and proposing the Data EX. So I would like to talk about these 2 points today in my presentation. And then Connected Industries Open Framework is something that we're promoting in the Industry Value Chain Initiative. So that's where we are in Japan. So first of all, I'd like to talk about Data Society Alliance. So through the collaboration between academia, government, and the industry, we want to promote the fairness across fields through industry, the government, academia collaboration, and to create a prosperous society. And data DX is something that we want to provide as a means toward that end. So what is the data EX? In order to create, it's an initiative to have the cross-border data collaboration, and it's a data infrastructure based on the integrated specifications that we want to promote. The next one is Data Architecture Design Center. And the role of this is to orchestrate collaboration of multiple diverse stakeholders and design and promote the system architecture. So we had this talk before, but we want to have architecture across different domains, including legal systems. And it plays a role of review and promote these area. We, RRI, will collaborate with these organizations so that we can promote DX and Industry 4.0. Next, I'd like to talk about the importance or the significance of the manufacturing. This is what we discuss as part of our activities at RRI. It's a conceptual illustration. The manufacturing industry provides products to all areas and domains, not limited to just manufacturing. For example, mobility, energy, agriculture, food are all part of it. And they become as a service. And in the process, we try to aim for Society 5.0, including planetary boundaries. It's important to deal with these kind of issues. And as I mentioned earlier, manufacturing industry has been providing products to all different spaces, and we need to continue providing products to all parts of society. So this is my first hypothesis. And the second point is the planetary boundary is becoming an absolute condition. And in terms of the needs, this is becoming very diversified. And recently, we're seeing a very unstable international situation, including pandemic, and also large-scale natural disasters are also having a large impact on the manufacturing industry. Today, I put on the tie colored in Ukraine. Try to emphasize that it's black, by the way. As we try to promote these kind of activities, as Dyck-san mentioned earlier, we cannot deal with this current situation just focused on the certain local area. And as we heard from the two presenters earlier, we need to come up with a structural innovation. I think we are now in such an era. So we reconsider what innovation means. Industrial revolution is where the technology will first come, and then that would change the society. Yesterday, digital was talked about. It's a big technology. It's a big transformation. It has the potential to transform in a massive way. But what is the purpose, and how are we going to implement this in the society? And we come up with this thing called innovation dilemma, and also the systems may cause unexpected emergence. Therefore, we need to consider these points and come up with the right design. Earlier, I talked about the structural innovation and unexpected emergence. We need to come up with a system to address those unexpected emergence. And I think the manufacturing technology should serve as a base. In order to address digitization, and I think it's become more important to standardize the manufacturing technology. So we need to conceptualize. There's also simulation models. So we need to digitize those models. And I think we need a model or the infrastructure to have those things. And another perspective that we need to think about is to look at the society as a factory. Society, cities, and all industries could be considered as a factory. The manufacturing technology and the management and the Kaizen could be applied to all areas of the society. So this plays a very important role. Therefore, we need to make it systematic so we could share this across different domains and make it available for everyone to use. I hope to have a good discussion on these points. I'll skip some slides. So one of the important examples that I want to highlight is, I think this is quite famous internationally, so maybe a lot of you are familiar with this. So starting from the manufacturing side, I hope you can see this arrow. The components will be supplied in the supply chain, and also the equipment will be provided as a production goods, and this will be passed on to users. In the case of ag, their machining tools provided, and they will process vegetables and rice, for example. And in the case of food industry, they will be provided as an ingredient. You can see that you have to look at this as a whole. And this example focuses on the civil engineering. It's also a famous one. In this case, sand and soil will be scooped up and it will be carried by truck to another place and they will develop the land in another site. For example, the soil, when carried by the truck, there is a limit to its load. Traditionally, you put the soil on the truck and you can travel if it's not exceeding the limit. But when it comes to construction machines, we know that they can calculate or measure the weight itself. So the machine will measure the weight and calculate how much they can carry. We can shift to such a style, then we don't have to line up the trucks before in front of the measuring equipment. And also the civil this construction throughout, including the carrying of the soil and building up the soils. If you consider this a process in the factory, we can think about how we can manage this smoothly and make it smooth as a process. And these kind of services are already being implemented in some places. And a lot of different type of manufacturing technologies are being utilized in this process. In all industry, the manufacturing is providing. Industry provides products to all industrial fields, and it's involved in manufacturing technology. This manufacturing technology should be systemized, and if we can standardize them, and we believe that will promote the data usage in various areas. Actually, in Europe, Germany, and America, such things are starting to take place. Therefore, I think we need to pay attention to these once again and think about what we can do. So that is all for my presentation. Thank you very much.
Mr. Mizukami, thank you very much. Now we'd like to begin the panel discussion. Mr. Dyck is reconnecting through smartphone. Can you hear me okay? Now let's begin the panel discussion. So I will first talk about how we will go about panel discussion as well as the panelists. The panelists are the speakers from earlier. We have Dr. Kagermann, Chair of the Acatech Board of Trustees, Mr. Dyck from SESMI, and Mr. Mizukami from RRI. And I am Irie from RRI, co-chair. I will be moderating the panel discussion. So today's panel discussion has these themes for discussion. The first topic, well, we heard from the speakers today about ecosystem. So throughout the ecosystem, what kind of challenges do we need to tackle, and what is the goal that we are trying to achieve? From 3 different regions, we want to hear their opinions and align our understanding on the challenges that we are all facing. And the second topic for discussion, based on our understanding on how manufacturing should be to tackle these challenges, today in how the digital spaces should be today, and how should we create the real and physical ecosystem. That is what we want to discuss as the second topic. And the third topic for discussion, RRI is currently having discussion on this topic, and Mr. Mizukami also talked about this, but manufacturing is not contained in manufacturing industry. It has impact on other industries as well. So we want to talk about collaborative system as a social infrastructure. And also, as I said earlier, we received some questions from the audience. So we will be taking some questions from the audience at the end. And then in closing, we will hear from Dr. Kagermann and Mr. Dyck on their expectations toward Japan and RRI and close the session. So this is the flow of today's panel discussion. So I would like to summarize the challenges surrounding manufacturing industry today. We are now in a very volatile era, and the initiative toward decarbonization is undertaken, as well as on the circular economy, how to utilize resources, and disasters and pandemic. In the last few years, we have been facing this challenge. And also because of that, supply chain has been disrupted. It is a significant challenge for manufacturing industry. And the other point is digitalization and associated risks, such as security risks and digital divide. And these are some of the emerging challenges. So in the last few years, the environment surrounding manufacturing industry have been changing dramatically. So that is the background. And now on the first topic of discussion, at the bottom, you can see the value chain in manufacturing. The manufacturer, in the upper stream of the value chain, there are material and ingredient suppliers. And then once products are manufactured, distributors distribute the products to the end users. And R&D, finance, logistics, energy, or important IT and IoT are supporting these processes. And vendors are creating that infrastructure. And as Dr. Kagermann said, this is not flowing in one direction, but they all have to be connected in a circle. That's the kind of value chain that is being created today. And in the whole value chain, as you can see at the top, throughout this value chain, how can we tackle these issues and challenges at the top? So the starting point of Industry 4.0 was smart manufacturing. So how can we make operation more efficient, and how can we add more value to user experience and users? That was the beginning. So that's some of the challenges. And also the quality control and supply chain security and sharing economy in the downstream. And throughout the value chain, decarbonization and circular economy initiatives are being undertaken. So this is the overview. And based on this, I'd like to hear from everyone on what they are focusing on. So first, Dr. Kagermann, I'd like to ask you, so at the beginning of your presentation, you talked about circular economy, and throughout the value chain, you talked about the challenges that you have to tackle throughout the value chain. So what's the take on that in Europe? And what is happening more specifically, especially when it comes to the efficient operation of plant and the circular economy and the other notion? They might be contradictory. So can you talk about how Europe is Europe's take on the ecosystem as a whole?
Yeah, thank you. I would like to point out that the key, I would say, difficulties we still have is, as I said, in the area of design. I believe that in manufacturing, we are well underway. Nearly all European countries have initiatives like that. In the US, we have just heard about smart manufacturing, those in Japan, that you find nearly in all countries in different ways, but most of them, I would say, based on the Industry 4.0 ideas. Then you find pockets of innovation around recycling. that's interesting that people focus so much on recycling, but as I try to point out, that's just not enough. It's a last resort, so to say. And if I look to the products we are producing, let's face the fact, I think in the last 10 years, it's close to what John said for the legacy in the plants. I think the product gets less and less reusable and less repairable. And I think that's where we have to start now, rethinking and motivating people. I think to really start with a completely different design. The second challenge is so for me it's not so much manufacturing. The second challenge then is what was outlined from Japan, these as a service. If you offer things as a service, for example, in mobility. I worked now for 10 years in this, and I've talked to nearly all people from the society, moving people from buying a car to using mobility as a service. Isn't that easy? Because today a car is still the most convenient way to come from A to B. And last year we have tried to test these in a real-life lab in Hamburg in the International Transportation Symposium and implemented some of these autonomous vehicles like Japan did it as well. And the outcome is that the cost is still by far too high. So at the end of the day, the consumer are not willing to accept these on a broad scale until we have really autonomous vehicles. So you see, there's a lot of things that are intertwined. And so in our case, to conclude that, our government is more and more directing us into a way where we include the consumers, the citizen, much more at the beginning when we start to architecture the systems of the future, and in order to get the input of their desires, their intents, and what they really want to have. And finally, that's easy to use for them.
Thank you very much, Dr. Kagermann. And one more question to Dr. Kagermann. As you just mentioned, the design and what to do with legacy. The traditional Industry 4.0 goals, well, in the current development, visions are being revised. So the conventional smart manufacturing movement in the past, in terms of the percentage of achievement, how much, to what extent have we made achievement?
Yeah, thank you. It's a good question. I ask the same question in Germany always. I would agree with John. I would say in Germany, we made the last survey 18 months ago, and at that time, let's say 98% of all respondents said that they need to move Industry 4.0. That's a good achievement. That was not the case 5 years ago. So everybody knows he has to do something. And you know that we have developed this so-called maturity index with the 6 stages in order to get to final adaptability. The first 2 are connectivity and computerization, which we call Industry 3.0. And John has lined out, let's say, what a mess we have created in the past. Everybody has done that. And everybody, I would say 90% now is on the first stage of Industry 4.0, which is transparency. To get a kind of a data shadow, get the visibility, what's going on. I think here we are pretty well underway, but that's just the first step. And only 5 to 10%, and these are also the big manufacturers in Germany, are on the step of predictability, I would say. Nobody so far is on adaptability, nobody. But predictability is already good, I would say 5 to 10%.
Dr. Kagermann, thank you very much for sharing the data and valuable insight. Next question is directed to Mr. Dyck. The same question. In the United States, as you said in your presentation, I think that still smart manufacturing, how to facilitate smart manufacturing is something that you are trying to grapple with, and various stakeholders are being engaged and being involved today in order to make that progress. So are we going to make the processes efficient, or are you going to make the process efficient, or are you also trying to tackle other social issues as well? What is the focus?
Yes, can I ask you to confirm whether you can hear me or not? Okay, good, thank you. I have had some technical difficulties here. So first of all, I appreciate the other presenters, each and every one of them. I think they've done a great job articulating some of the really important and far-reaching impacts of both the challenges and the opportunities we face. But to get directly to your question, I think that there's two distinct ways of thinking about these opportunities and challenges. There's the large enterprises, and then there's the small, mid-sized manufacturers. And the large organizations, they have the deep pockets, they have the financial means to engage. But even for those manufacturers, what they have created over the last 3 to 4 decades is an enormous hurdle for them to innovate and to think about as they look at future architectures, future capabilities at scale. We've all heard of pilot purgatory, the extraordinary numbers of percentage of digital transformation projects that are not successful. By far the majority of these initiatives today are still struggling to succeed and struggling to scale out. And that's predominantly with these large, sophisticated, mature manufacturers. And so I do think it comes down to some really important cultural and technology challenges that we have to address. Without addressing those, which by the way is how we get to reducing cost and complexity for the small and mid-sized manufacturers, we won't be able to address the important societal challenges at scale either. The desired outcomes for most manufacturers start with meeting their production goals in a safe and high quality manner. The idea of sustainability and carbon footprint, while an increasingly important and strategic set of initiatives, rank, at least in the US, still for the most part, rank as priorities beneath most others in their list of priorities. Having said that, though, we're working aggressively to align the business value of sustainable manufacturing and of greenhouse gas reporting and measurement and reporting. We're trying hard to align the broad values of smart manufacturing and the outcomes of smart manufacturing, like better productivity, like higher quality, like more organized and effective supply chains, align those with the outcomes that can be aligned with sustainable manufacturing. When you reduce waste across a plant, an enterprise, and a supply chain, you've improved your energy productivity and you've improved your greenhouse gas footprint. When you improve your process efficiency, you've done the same thing. What we haven't done a very good job at is helping articulate these important smart manufacturing outcomes in ways that our organizations can attribute to and align with these important societal challenges. And so I think we have to do a better job across the board at ensuring that when we make a plant, an enterprise, a supply chain more efficient through these important smart manufacturing, digital transformation initiatives, that we are making direct and indirect impacts on our greenhouse gas strategic initiatives, on our ESG, environmental, social, and governance objectives, and the broader societal challenges that and requirements and measures that we all need to be working towards.
大工さん、ありがとうございました。
Thank you very much, Dyck-san. We have another question. The efficient factory management and the social decarbonization shift to circular economy. So would it be possible to achieve those two? I was asked about, I was going to ask this question, but it seems like you're going to promote this, trying to balance those two and try to achieve both with them. That is how I understood hearing your talk. Thank you. So I would like to also ask a question to Mizukami-san on discussion 1. In Japan, I think it's quite polarized, personally speaking. Industry 4.0, smart manufacturing, especially when it comes to SMEs, it's not really progressing. On the other hand, there are large social issues that's really coming to us, and I would like to understand how you see this situation. When it comes to servitizing, I think there's not much awareness or recognition of it. Earlier, so I was listening to what is happening in the United States. I don't think there's much difference between Japan and other countries, perhaps. But how we can create a new product out of information or data is something that we need to really seriously start to think about. And it's becoming more important to take action toward that end. Earlier, PSS, product service system, is the word that I used. But this is not well known at all in Japan yet. And raising the awareness of these concepts or words and is important. And also there are some use cases in Japan already advanced. So I think it's important for people to get familiar with these kind of concepts. On the other hand, Dyck-san said that the SME issue is a separate one. Actually, in Japan, small and medium-sized companies collaborating in the manufacturing and design space. We are starting to see some examples of that happening in Japan. And maybe we can think about how we can make this into like a servicizing or trying to contribute to society. We hope to get a lot of inputs from various areas so that we can come up with a good example. And I think, one of the important roles of RRI is to take up those examples so that people will be more aware of this. Thank you very much.
So especially at the beginning of your presentation, you talked about PSA, data EX, and DADC. So these are in these areas, you have not defined any focus areas.
Well, finally, when it comes to manufacturing and digital, I think we're starting to see some kind of movements or momentum to really start discussing these topics. We need to accelerate these moves going forward. Today, I said that unless we can share the manufacturing technology, we will not be able to create a foundation. I said this because of those reasons.
Thank you very much. Now we move on to discussion topic 2. Topic 2. Well, earlier we shared the sense of challenges. And in order to solve these challenges, what we believe is important is in the middle of the slide. It says virtual space here, but Dr. Kagermann calls this data space or digital twin. So they need to have the reliability as well as sovereignty And between the value chain, data needs to be exchanged and shared. And it is important. I think that all the speakers talked about that. But the approach to achieve this is probably different from one region or one country to another. That is my understanding. So, Mr. Dyck, I'd like to ask you the first question. In your presentation, you said that about 160 companies in SESMI are working together, and the actual companies are forming the community. So, how are they working together more specifically? If you can talk about specific cases of their initiatives, I appreciate it.
Yeah, I think that's a great question. I'll share two examples. One fairly horizontally around the supply chain challenges that we are trying to address, and the second as an industry group focused on these challenges. When in the early days of the pandemic, excuse me, it became clear that the supply chain challenges that we faced in trying to respond to dramatic swings in both demand for and the ability to supply materials and goods for a disrupted marketplace. The many manufacturers struggled to adapt and to respond, and so as an outcome of that, we pulled together 6 large manufacturing organizations and a few technology providers. The manufacturers included Procter & Gamble, Johnson & Johnson, General Mills, ConAgra, Honeywell, and Raytheon from across a number of different industries, as you hear, to understand how we can develop a standard for, I'll call it a de facto standard for how manufacturers and suppliers can exchange data in real time about their manufacturing operations. The challenges that these manufacturers faced highlighted or really underscored that in times of massive disruption, most of the communications was still via email and phone calls and even faxes. And so the idea of exchanging data in real time for various different functions, quality and throughput and overall capability and capacity in every step of your operation and distribution system, those became vital requirements. And so that's what we did to convene an ecosystem from our membership to pull together a standard approach to accomplish that. And we're still working on that. But I think that's a good example of how organizations at in virtually any other setting would not be working together to solve big challenges. Another challenge, or another example rather, is with the automotive industry. We've been working with GM, Ford, and Stellantis to build an automotive smart manufacturing roadmap. And just incidentally, as a part of that, in our conversations with our friends from Germany at the Plattform Industrie 4.0 organization, we've been able to bridge the conversation and the work around both Katina X and Gaia X that we both heard today from Mr. Kagermann. And so we've been able to ensure that the work that we're doing in the US is, again, harmonized with the activities that are happening in Germany and other manufacturing regions. So again, two examples of how we work together to convene different stakeholder groups to ensure harmonization and ensure that we're focused on collaborating to solve important pre-competitive issues like the ones we're discussing here.
Thank you very much for sharing 2 insightful cases. I was able to picture what you are doing more specifically in SESMI. So you talked about the initiative still be ongoing, but you are creating a library so that library will be open to many people to use. Is that what's happening?
That is exactly right. The library of applications and information models and tools for smart manufacturing are available to anyone. There are additional benefits for members that are part of our membership, but specifically those around available to anyone around the world. And that's part of the reason for collaborating with and harmonizing these important activities across other manufacturing regions like Japan and Germany, because wherever we have organizations that understand the value of these capabilities and the value of partnering and critical mass and momentum, we all have issues commercializing the capabilities that we are investing in. I believe that this is how we can do so in a much more effective way.
Thank you very much for sharing your initiatives. So Mr. Dyck mentioned Gaia X and Catena X. So I'd like to ask the next question to Dr. Kagermann. In yesterday's session, Catena X was introduced, and I believe that Europe is leading that initiative. But as we heard earlier, and as we heard yesterday, Volkswagen and SAP representatives talk about that initiative, and I understood that they were driving and leading the initiative. But if we are to make this ecosystem, then small and medium enterprises and other stakeholders and players from different segments need to be involved and engaged. So what kind of activities are happening in Europe?
Yeah, thank you. I think you have seen in Catena X that is becoming popular for two reasons. If you look deeply into the repository of use cases for Gaia X, you find nearly 100 of them across all industries. But Catena X is by far the largest and I would say most powerful. Why? Because when they were founded, Catena X, it was driven by a few very, I would say, powerful industries from top management. That makes always a difference. And the first founders have been BMW and SAP. And then they opened up to have more. But you cannot open up to hundreds. You have first of all to manage that you open up to 10, 15, because otherwise the momentum goes away. So you all know how it's a business, yeah? And so in the meantime, you see more around them. So therefore it's powerful. But I guess that over time, they will open up even more. And because that was the most successful and promising approach, there are several approaches, and sometimes people feel it's still too slow and it's not scaling. It seems to be the one which is fast and scaling. That's the reason why people have not followed up the idea of an industrial data space, but saying, let's just take the lessons learned from Catena X, expands this to the entire manufacturing industry, as I said, and expand it into manufacturing X. That is just at the beginning. I think there will be next week another steering board with our ministers where exactly this point is at the table. And that means at the end how much funding will be there from companies, but also from the government, and how much support. Because once you start that, then the government has to go from Germany to Europe and to see that at least on a European base, we have collaboration. And once we have a European collaboration, we will reach out to the other countries. That's a normal way, yeah? So therefore, this is one initiative. There are others. I don't know if they were mentioned, but it relates to your name, Robot Revolution Initiative. we have seen on the European level that we had several initiatives, let's say one around data, another one around advanced robotics, another one around big data, and the next one around industrial or artificial intelligence. And recently, I think it was last year, they brought 3 of these initiatives around big data, artificial intelligence, and robotics together, in order to say, let's harmonize, as it was said, and let's not work again in silos. That seems to work as well. There are many others, but the last one, which I just mentioned, is pretty powerful, pretty big. On the other side, that is my last comment, you have seen that the platform industry 4.0 works now for, I would say, since 2013, yeah, roughly 10 years. It's close to 10 years. And then over time, topics become more mature, and you can, like in a company or in a university, can spin off a kind of an enterprise, which was done around the digital twin, which was done around several other topics, or the Labs Network initiative. So on the other side, whenever we feel a certain topic is big enough, independent enough, then we try to make it separate, but keep the platform industry 4.0 as the overarching, I would say, organizational entity to keep things together, and in particular working with the international partners, with the US, with Japan, with everybody in Europe, etc. Yeah.
Dr. Kagermann, thank you very much. So data space, the concept on data space has been discussed for more than 10 years, and I think that strategically worked on. So for the last 10 years, strategically continuing the work on data space, I think is quite difficult from a Japanese perspective. That's what I think. But what is the tip for continuing such work strategically?
Yeah, you have to push, and you have to push hard. I can say you our experience. We started at the very beginning. There was big concerns 10 years ago, in particular from the SMEs, to protect the IP. We discussed this several times. So we presented it, but nobody really wanted to move. You know, amongst us, amongst the countries, it was about agreeing on standards. In the meantime, we are above them. John talked about harmonization of the concepts, which is very good, but was not there at the beginning. And the SMEs were extremely, extremely resistant to share their data. That's much easier for big ones. So I can say in Germany, what happened was a few years ago, I would 3-4 years ago, our government, Angela Merkel, made a big move and really not forced, but requested, in particular, the car industry, that we come to a data space for mobility, which was also, let's say, supported by acatech. But at the end of the day, that's the highest level in the government addressed to the highest level of the business, that's now needed, pushed things forward, because then it had to be reported back, let's say, to I would say a group we had led by our chancellor, but where we had also other politicians, leading politicians in, where we had the CEOs of the leading automotive companies. You see what I mean, yeah? And if you have this ongoing for 2 or 3 years with a request that the data space is so essential, then finally something happened, also because part of the data we need are publicly owned, from the rail, etc., where the government is 25% the owner. So therefore, that has helped at the end of the day, that now everybody understood. There was a first move, the key parties came together, and you know, when 30, 40 are coming together and take it seriously, others follow, and that has happened. And now building on this, the others see the success, and now you can expand to other industries. So we were lucky that happened in one area, and now let's say we copy more or less the same thing. Okay.
本当にこれまでリードされて。
So thank you very much for a very valuable comment as a leader of such initiative. Next, similar question to Mr. Mizukami. In Japan, as you said, Mizukami-san, DSA and DADC initiatives just started. And regarding these virtual spaces, the understanding is being deepened. So what is the current movement? What's the current development? In order to drive such development, what is the challenge?
Well, yesterday, in the day one of this international symposium, Mr. Saka said this, but I think the industry barrier is very high. The wall is very high. Maybe this is the same with other countries, but I think it's very siloed, including the government organization. So I think that is a big hurdle or barrier. But as we try to address this in reality, what we need to do is to find use cases within this kind of siloed structure and try to overcome those barriers so that it could be used in the other spaces. And I think, we're starting to see some of those discussions starting to take place. And RRI haven't been able to really support this directly, but as we collaborate, we are providing advice so that people have a good understanding or better understanding of this. So we're working on it. Earlier, Dr. Kagermann talked about the importance of the silo. You talked about AI, and that is going to change the importance of a BPI. That is going to change how we do the business. In Japan, the BPR in the space of IT is not really successful. So we introduce a lot of ID that is partially optimized, and we have a lot of legacy. And large enterprises and big players are struggling, and they're starting to understand the significance of switching and shifting. When it comes to SMEs, it hasn't really progressed because they're lagging behind. How should I say? They're able to introduce something totally new. I think there is an environment for them. But having a good understanding of the situation so that they'll be able to make use of it, I think they may be able to introduce en masse if they understand. But I think we need to work on Kaizen activities to understanding what we need to do. I think there's a lot of potential in Japan, and we do have the ability to do so. So I think we could make an effort. But in Industry 4.0 initially, and also another area that you might be struggling, what is the significance of having a shared understanding? What is the benefit of it? What do we need to think about? I think these are the areas that we need to communicate so that more and more people will have a good understanding of this. So these kind of study activities are very important. RRI has plays a role of lighthouse. This is something that we've been saying from 2019. We need to tell people what is happening in other countries to the people of Japan, and also try to work on things so that people have a basic understanding what is going on, so that we will be able to break down the silos and be able to connect even more. That's what I believe.
Thank you, Mr. Mizukami. So in order to drive these, you first have to establish use cases within the silos. Mr. Dyck talked about supply chain, and Dr. Kagermann talked about Catena X and circular economy. So that's what they are working on. But in Japan, is there any discussion on specific use cases?
Yes. Our industry structure is very similar to that of Germany. Therefore, so we have been focusing on the automotive industry from the early days. Therefore, GX, green transformation, together with the GX, I think we're starting to have this discussion focusing on that area. However, this is not a system just for that. As I said earlier, the manufacturing technology is actually supporting all this, and we need to have good understanding of it. This is very important. And when it comes to individual areas, the Catena X started with 16 applications. Therefore, as stated, I think we need to build up from the bottom. So I think there's a need for a mindset shift. We shouldn't just focus on what is happening just in front of us, but think about how we can solve other problems together with what is happening around, so that we will be able to progress even further. And I think we're starting to build this environment where we are able to say and speak up on those matters.
Thank you very much. So time is quite limited, so we want to move on to the third discussion point. So Mr. Mizukami said in the presentation that we are currently discussing whether manufacturing can be a social infrastructure. As you can see on the slide, for example, in other areas like energy, mobility, food, natural resources, and agriculture, mining, the manufacturing is providing products to these other industries, and digital spaces are also led by manufacturing industry, which can be applied to other industries. So manufacturing can serve as a social infrastructure. That's what Mr. Mizukami talked about in his presentation. So expanding and scaling up digital space or ecosystem, I think that's what we are saying here. So Dr. Kagermann, I'd like to ask you, so regarding this way of manufacturing's presence, what's your view on this idea of manufacturing as a social infrastructure? I think it's quite similar to the movement on Gaia X. Is there a similar movement and development in Europe like this?
No, I think it's a quite new idea, and it's interesting to debate it, because that we have, you mentioned it, that we have started all our things with manufacturing is obvious. I think in Germany it was because the backbone of our I would say success of our economy. The same is in Japan and in the US. I listened to let's say a vice minister in 2011. He said there are better jobs in manufacturing. I hope, John, this is still the case. So there was something to say, okay, let's do this first, and then from there go to the others and influence them. In our case, what I would say is the concept of digital twin, for example, that is everywhere. In smart city, and even you make digital twins for humans. So therefore, I think in city, everything you mentioned, the digital twin is everywhere. Fine, and it came from manufacturing industry. Data spaces, the same thing, will be everywhere. The idea of a business model which is around what we called smart services. You talked about connected industries, but at the end, servitization, productation, everything as a service for the user, the best experience, bundling everything together to fulfill his desires, getting the job done, as Clayton Christensen said. These type of concepts, I think, go across all other topics, no doubt about that. And I think are best developed out of manufacturing. So all of these things, I think manufacturing can play, I would say, a role of a blueprint. My only question is, but I don't know if we have the time, is I was thinking about if you would see software development and hardware development as both as manufacturing, because we have seen that the let's say bringing manufacturing industry to understand that software is so much different, but they have to combine both, was one of the biggest hurdle we had here in Germany. Because from a cultural point of view, from the managers to understand that is different, but they have to bring both together. That is for me one of the key criteria for success if they understand this. So therefore, if you see both as manufacturing, I'm fine, yeah, because we bring the virtual and the physical world together. But otherwise, I agree. I think it's a blueprint for the other sectors, from my point of view, yes.
Dr. Kagermann, thank you very much for your comment. So I'd like to ask the same question to Mr. Dyck. So what do you think of this concept of manufacturing as a social infrastructure from the American perspective? In the US, I know that the manufacturers are trying to improve efficiency, but in the end, the value needs to be created for the end users. So so whether we can expand this concept internationally or not, what's your view?
Yeah, I think it's a fascinating question. I would concur with much of what Mr. Kagermann just said. I would add to it from a U.S. perspective that I think the U.S. is known for its citizens being very individualistic, and I think we embody many of those individualistic characteristics in our approach to manufacturing, and so whereas I think the idea of collaboration and even engagement of government and the administration with manufacturers is a well understood and I think a fairly mature concept in both Germany and Japan. That's not the case in the U.S. And so we from a private-public partnership perspective, as the Smart Manufacturing Institute here, meaning SESME, we're blazing some new trails just to get these manufacturers and these machine builders and technology providers to work together on a roadmap simply for the work that we're doing here in the world of smart manufacturing. And so what's really fascinating though is that the world is changing quickly, and the pandemic I believe certainly underscored how important it is for manufacturers to engage more in a more collaborative way and develop these partnerships with each other and with the government and with other associations and mission-driven not-for-profit organizations that can help in these important ways to blaze a trail for the future and ensure that we don't fall behind. As I mentioned before, there is a very clear understanding that the U.S. Adoption of these important capabilities is lagging many other parts of the world. So I think we're on the precipice of doing some of these, of bringing these ideas to the marketplace. But I think at the foundation of this kind of transformation is this idea of at least in the US, of a business model that drives everything. Meaning if it can be proven to enhance my business model in a very sort of almost individual organization environment, if it can enhance my business model, I'll consider it. If not, I'm going to perhaps engage. I'm going to learn, but I'm not going to invest in it. And so that's perhaps a too pragmatic a response, but I think that's where we would how I would respond to that.
Mr. Dyck, thank you very much for valuable insight. Yes, so business model and how to monetize. That is the driving force and driver of decision. So based on these comments from Europe and the US, I'd like to ask Mr. Mizukami how to go about this.
Yes, I think we need to find a space where we can collaborate. This is something that it's like a slogan. I mean, I think we need to discuss and come together with other domains, people from other industries, and I think we need to continue to make such effort. Earlier, Dyck-san talked about business model, and Dr. Kagermann talked about B2B platform economy. There's having discussion of this kind of large issues, and I think all of them is connected. So I think we're starting to study these topics. But where we're strong in is, well, we have this Toyota production method. So I think this kind of bottom-up method is where we're strong, and I think this is important. Currently, maybe we're relying on people, it's people's know-hows, but maybe there are things that we could share. That's because that's more beneficial. I think there's a lot of those things. Toyota production method is one example, and we learned in the rental cars, and we adopted, and it really improved the efficiency. We know that there's an example, and this is one of the base. We try to do the sorting and setting in order so that people will be able to really see and understand what is going on. So we change the structure. It doesn't sound a big thing, but I think these kind of things are very important. And digitization asset is also another topic that we all often talk about. So the position of the asset, that is also an important information. So it's important that people understand and realize that we should share what we do. If we can really understand this, I think we'll be able to contribute more to the world, and I hope we can work on these things together so that we can collaborate further.
Thank you, Mr. Mizukami. Today's topic is quite broad topic, but in working on that, we really need to make a steady effort. So these were the topics that we prepared in advance, and from the audience, we received some questions, so we just want to take one of them since the time is limited. So in order to establish ecosystem, that's one of the topics that we have been discussing, but in order to establish an ecosystem, I think that we need to be aware of planetary boundary, because it's a global notion and challenge that we have to share. And what do you think will be important? Do you think education is important in order to share that notion? What else do you think is important? So Mr. Dyck, on education, can you respond to this question?
Yeah, I think this is another really important topic. The education that's provided for those that end up in a manufacturing setting, whether it's on the manufacturing shop floor or those that are in engineering or in IT or in leadership. The challenge is how do you blend the things that you're teaching your students in academia with the prevailing culture in those manufacturing organizations. And because if the students that are graduating and showing up in a manufacturing context are not aligned with what the prevailing initiatives and the cultural appetite is, there's obviously going to be a misconnect or a disconnect rather. And so I think we in the associations and the organizations that we represent at a national level need to do a much more effective job educating manufacturing leadership on how we can transform the culture of our organizations to facilitate this next generation of workers, this next generation of leaders that are coming from our educational institutions with much different ideals. The ideals that they represent, I think, are much more aligned with some of the things that we've talked about here: the ecosystem, the sharing of ideas and information, the focus on sustainability and a concern about societal issues. I think that's much more likely to be the mindset of the younger generation that's graduating now. And so we want to make sure that they find a good home in manufacturing and can build those and develop those skills versus having them systematically quenched, if you will. So I think it's really important for all of us in the positions that we represent to establish a much more effective dialogue for these topics, so that the academia, the knowledge ecosystem, and the manufacturing ecosystem can work together more effectively.
Mr. Dyck, thank you very much. So the same question goes to Dr. Kagermann regarding planetary boundary, how to change our mindset. What do you think is important education, or it's something else?
Now it's two things, and the most difficult is first shared values, as we just see in the world how it's changing in the last months. At least I hope we can agree on a subset of values. And once there is an agreement, and it seems to be that at least climate protection is something everybody agrees upon, there are other values where we don't share, and we have to overcome this. Then exactly, I agree with John, the next thing is education. And I think education is a core topic. And in our case, as I said earlier, it's not just education in a traditional way, it's also including the different stakeholder and groups of a society extremely early into the debate. That is something new that makes things, unfortunately, a little more complex, but it's just necessary, I think, because we see so many unpredicted events and so many unintended consequences that it's important, I think, to involve all the people from the beginning. And that's a little bit what we are doing to finalize that. I think there's a concept so-called real life labs, which is very popular in Germany. And it's also, for example, to include the regulator very early in order, in addition to all the innovations we are doing, that we all get regulatory innovations as well, which is necessary.
Thank you very much, Dr. Kagermann. So same question goes to Mr. Mizukami. So what do you think is the challenge?
In Japan, from some time ago, we have been doing this environmental education for grade school kids. So I think children these days do have an understanding what environmental issues are about, and these children are becoming adults, the Gen Zs. Similarly, again, back in the Edo period, so Sampo Yoshi is like a win-win-win situation, trying to make sure that people understand how ecosystem is very important. I think we need to really include this in the education, maybe for the elementary school kids. So I think that's something that we need to do, and I realized that throughout discussion today. But on the other hand, children have to go through the entrance exams, try to study for that. So I think it's important to really create an environment where children can think about these important issues. Other than education, what is important is, as Dr. Kagermann said, I think it's important to have a discussion. It's important to hear from many people as much as possible. What I often say is, we also always say pros and cons should be heard. We have to hear people who agree and people who disagree. And you need to make judgment, make decision on your own after hearing both sides. And people have to be able to do that. Because nowadays, I think people, when they join a company, they may not be able to get used to these kind of things. So I think that's important. So that's why I realized throughout today's discussion.
Thank you very much. I know that there are many more questions, but it's already time to close the session. So before closing, I would like to ask Dr. Kagermann and Mr. Dyck on your expectation toward Japan and RRI. Dr. Kagermann, please.
Yeah, thank you. Normally, when I talk about digital transformation, I start with a digital factory like we did it today, and then I come via the business model to the digital ecosystem. But the final step, if it comes to society, I think is a connected digital economy. And we have seen the difficulties, I would say, in the last years. Therefore, my hope or my wish to you is continue this session, because we are sitting here as representatives of, I would say, 3 of the top economies from different continents. And we have different history, we have different culture, we have different approaches, but we have different strengths and capabilities. And I think if we could combine them much more, I think we could create also a kind of a role model for how a connected digital economy could look like. Because we represent these 3 continents, and as John said earlier, we represent different cultures. So therefore, I would encourage you to do these discussions and encourage all of us to be even more open than we have been so far, to come to a win-win situation and to acknowledge the strengths of the other and to combine them to something which is even better together.
Yeah, I'll jump right in and say I would echo exactly what Mr. Kagermann just said. I have so much respect for what Japan has done and how what both Japan and Germany have done has influenced U.S. manufacturing, and it's been a privilege over the last 2 years to work with the Plattform Industrie 4.0 organization, and beginning now to work with RRI more closely. I anticipate the same sort of epiphany. We realized that working together really helped us balance our respective cultures and our approaches to solving problems. And what that meant was that we have a unique set of contributions as we engage together for that win-win-win. And so from my standpoint, I too would just echo the request, I think, to continue to invest in this collaboration and these conversations and these important dialogues that help us understand more effectively how we can work on these issues, these really important societal issues together. The world is getting smaller and smaller every day, and that I think really underscores the need for these conversations to happen and for us to discover how we can leverage the work that we're doing individually and collectively. And so I would just I guess close by saying that there is strength in numbers, and the 3 manufacturing regions represented here today each have unique strengths and unique perspectives that can help the others and accelerate the efforts of the others. And that's been my experience, and I'm grateful for the chance to be part of this conversation. I've learned much already today, and hopefully my contributions have been helpful as well.
カーマン先生、大工様、本当にありがとうございました。
Dr. Kagermann, Mr. Dyck, thank you very much. This concludes panel discussion. Thank you very much for very useful and valuable insights. Once again, thank you very much.
Thank you.
Thank you. Thanks.
最後になりますが、
Before we close, I would like to announce the schedule for day 3. Let me share my screen.
明日10月13日は日本時間
On October 13, tomorrow, from 5:30 to 7:20 p.m. Japan time, there will be a session. Japan-Germany Expert Forum will talk about the progress in Japan and Germany. I hope you will come back and join us again. This concludes the day 2 of International Symposium. Thank you very much to the panelists and the audience. Goodbye.